PHY205 Physics Laboratory experiment. Number 3. Resistors in series and in parallel. Investigating equivalent resistance using voltage current measurements. 1. Objectives. Investigate resistors connected in series. Investigate resistors connected in parallel. Measure voltage and current for different circuit arrangements. Determine resistance from the slope of the VI graph. Compare experimental and theoretical equivalent resistance. 2. Apparatus. DC power source. Ammeter. A. Voltmeter. V. Rheostat resistor. R1 resistor. R2 connecting wires 3. Ohm's law do V equals IR, where V equals voltage, volts, I equals current, amperes, R equals resistance, ohms. From the VI graph, slope equals resistance, R equals delta I delta V4. Series connection. In a series circuit, the equivalent resistance is greater than each individual resistor. Req equals R1 plus R25. Parallel connection. In a parallel circuit, the equivalent resistance is smaller than each individual resistor. Req1 equals R11 plus R216. Experimental procedure. Connect the circuit for R1. Vary the rheostat. Record 5 pairs of voltage and current readings. Replace R1 with R2. Repeat the 5 readings. Connect R1 and R2 in series. Record voltage and current readings. Connect R1 and R2 in parallel. Record voltage and current readings. Plot V versus I for all 4 cases. Determine R1, R2, RS, and RP from the graph slopes. Compare experimental and theoretical results. 7. Data table. Table 3.1 columns. R1 ohms, V volts, I milliampere, R2 ohms, V volts, I milliampere, R1 and R2 in parallel equals RP ohms, V volts, I milliampere, R1 and R2 in series equals RS ohms, V volts, I milliampere. Trials. Trial 1, Trial 2, Trial 3, Trial 4, Trial 5, 8. Graph analysis. The graph is voltage V, volts, versus current I, milliampere. Lines shown, RS, series, R1, R2, RP, parallel. The resistance is determined from the slope of each line. R equals delta I, delta V9. Calculations. Experimental values from graph R. 1 equals a slope of R. 1 graph R. 2 equals a slope of R. 2 graph RS equals a slope of series graph R. P equals a slope of parallel graph. Theoretical values for series connection. RS equals R1 plus R2 for parallel connection. RP1 equals R11 plus R21. Compare experimental and theoretical RS and RP, then calculate percentage difference if required. 10. Lab report questions. What is the slope of the VI graph? What does the slope represent? Which connection gives a larger equivalent resistance? Which connection gives a smaller equivalent resistance? Why is RP smaller than R1 and R2? What conclusion can be drawn from the experiment? 11. Final conclusion. Resistors in series have one current path. Series equivalent resistance increases. Resistors in parallel have multiple current paths. The VI graph is linear for resistors. The slope of the graph gives resistance. The experiment confirms Ohm's law and the rules of resistor combinations. Parallel equivalent resistance decreases.